Hello, everybody. Let me introduce myself and my talk. So, ready, steady, R2DBC. My name is Roman, and I am a Java developer. I'm developing serverless framework for one of the Russia banks. Here are my contacts, so you can contact me via Twitter or Telegram. Here we go. So, this slide shows a report which clearly displays part of the market that a relational database occupy. They have been around for decades and they are still popular. They do not lose their importance because they do their job very well. Especially a configured relation database can withstand incredible load. Many teams choose relational database when creating new projects because they are well known and reliable. The need of their databases of other databases occur when the business gets very big. So we need for customized solutions for speed and data analysis. This short talk will discuss one of the most important topics, building entirely reactive application. So reactive programming has enabled a new type of application that is highly reliable and fast under load. The reactive approach has made it possible to do more valuable work per unit of time while consuming fewer resources. Most of the time, the application we use have to receive, process, and store information. So for the most part, there are CRUD applications. Let's look how a classic Java application worked before the appearance of reactivity. So suppose we have a server with a single thread. We process a request from a client. The client wants some information and send a request to the server. So the server reacts in the following way. It allocates a separate thread for client and handle the request data in this thread. If we need to retrieve some data from a database outside, the server in the same thread reaches the database. Network is one of the most unpredictable components of the computer world, and probably the slowest. It means that our request to database is very slow, and our thread is idle and blocked all request time. And I forgot add that we also expected the database to execute the query, and if the query is not optimally prepared or very large, then the execution time of such a query can be very long. While waiting, we cannot perform other tasks, possibly not related to database queries, for example. Why does this happen? As I mentioned earlier, relational databases were developed over several decades. And when access standards such JDBC were being designed, nobody thought about async calls and performance solutions. So computers were rapidly evolving, and programs could scale vertically very well, and it was quite enough to handle clients' requests. The JDBC standard was created more than 20 years ago, and it's totally blocking. But what do we want to see? We would like our thread resources to be used to the best of our ability. The thread must be able to do other work until a response is received from the database. This is exactly what reactivity requires of us. So how can we solve this? The first idea that comes to mind is making a separate thread pool to execute blocking code for database queries. You probably all have read the book on this slide. and you can find this idea there. Really, it seems like a pretty good and robust solution. Your whole program works reactively, except of the some part of code which will be blocked. The real beauty of the reactive approach is revealed when we get a significant load on our application. At low load, we could not see any performance improvement, and perhaps the application will even run slower than traditional application with blocking. But in this approach with thread pools, how will this thread pool behave under the load? Yeah. How do we determine which pool is good for us? Yeah, this is open question, and we don't have answer for them. Here, we get the same problems that we had before. We just moved issues from one place to another to write really reactive programs. All of their components should be reactive. So this is where R2DBC comes onto the scene. R2DBC is a new approach to working with relational bases, based on reactive streams principles. It stands for relational reactive database connectivity, and it's entirely independent. You can see on the slide, so it's parallel to JDBC. So the developers of the standard choose, on my opinion, is the best way, provides the most straightforward possible set of interfaces that the driver must implement to support the standard. I really like this minimalism approach, because it allows you to seamlessly fit it into existing code. The goal of R2DBC is to define a minimum standard of commonly used functions and use it. So it primarily target is relational databases, but it's not limited to them. It's provide only interface, so you can interact with any data provider via this interface. So R2DBC is also based, as I mentioned, on reactive streams and uses a concept of publisher and subscriber to provide non-blocking back pressure access to the data. This sets apart from other solutions, such as async libraries, like, for example, Oracle ADBA. There's libraries give you a separated interface and ask you to use callbacks and computable future to process the result. It was, it is not a very convenient way. And also, to be honestly, JDBC, we also can make it async. And JDBC has a chance to become async thanks to the Loom project, which should bring virtual threads to Java. And JDBC will still be an blocking API, but the thread that will be blocked will not consume as many resources as now. Still, we will not get a back pressure on subscribe mechanics and all the features of the reactive approach. But we could work with JDBC calls and consume more resources. Also, it's very important that now you can try all the features of R2DBC right now, and all you need is Java 8, but we don't know when Project Loom will be ready. So it's only about future, and in next talk you will know a little bit more about it. So R2DBC provides us service provider interface that must be implemented by driver vendors and also used by client libraries. So if you want to write your own driver, you will need to implement the following requirements, which are few. So you can see it on slide. Yeah, I copied from specification. First, you need to support basic SQL syntaxes. Also, your driver must support transaction. You should don't forget that index references to columns and parameters are counted from 0. In JDBC, it starts from 1. Yes, so be careful. And if your driver support parameterized statement, it also should support bind parameter tokens. Yeah, more detailed about this you can find in specification. You can find a link below on this slide. So the information at the moment, the release version general availability is 0.8, and the version under development is 0.9. Yeah, and as far as I know, the final version will be available next year. It will be 1.0. So version 0.8 is entirely usable, but version 0.9 gives us some significant functionality. For example, we now have a transaction definition interface. It gives us a more convenient way to use the unique transaction parameters of a specific database. And the second, I think, very important functionality, support for in-out parameters. So you can now work with stored procedures. And this is very important for me, I think, because there are a lot of them in legacy systems. Yeah, so for now, everything is, as I know, everything in version 0.9 will be in final version release. Okay, let's go ahead. Let's take a closer look at how the work goes with creating queries. Here we can see the list of interfaces that the driver must implement. The interfaces that don't have to implement all the methods are marked with asterisks. So you can see 3 interfaces we have at the end. To start querying the database, we need to create a connection to the database. Yeah, this connection interface describes the logical connection to the database. Let's see how we can get it. Sorry. R2DBC has a rather complicated chain to get the connection, but it's all hidden from us. First, the connection factories class. Yeah, you can see there. Here's the connection factory interface. Automatically loads all R2DBC drivers found in class path using Java service loader mechanism. Connection factories provide us 2 standard mechanics to begin connection factory loading. Yeah, first URL based and another optional based. So URL based, we give a string to our connection factories class, and R2DBC can parse your string and get all information from it. And you can add information about your connection with optional. Yeah, so you can use the builder and each parameter and add each parameter explicitly. The connection factory interface provides access to create a connection using a method create. Yeah, so as you can see, we don't have a connection object. We have a publisher that emits it. From the view of R2DBC, the connection object represents a separate client session, and each driver must implement the connection factory interface as a mandatory part of SPI. Drivers, this is very interesting. Drivers may provide multiple implementation of connection factory. It's depend on parameter which you gave to the system. We can change the connection string quite flexibly. For example, change the protocol, and for every such change, we can get new features to create the connection. So we can put there instead of a driver pool, so we get pull functionality to our connection factory. You can also, we have a second method, get metadata, so you can call it and get more information about driver itself. So only after item request, connection factory begins to creating connection. So we have a subscription and we have a method request, and when we call it, connection factory begins to create connection. And it should output exactly one connection or give us an error signal. If we cancel a subscription, the factory closes the connection and releases resources. When connection is established, we can execute SQL statements using a connection object, and the result are returned to us later. According to the documentation, a connection object can consist of any number of transfer connection to the database. So it's like abstraction on connections, real connections. Or on the slide, you can see a large list of methods available to us. We can easily guess from the names of what method, what they do. Yeah, so for example, yeah, we have begin transaction, commit transaction. After by default, we have after transaction commit, but if we want to manually manage it, so we could disable it, but yeah, we must explicitly start and clear each transaction by calling begin transaction and commit transaction method. And for example, if our database don't support save points, we don't have to implement this method, so we can only, for example, throw exception. So after, yeah, as I mentioned, connection has a lot of very interesting method, and you can use it. Okay, let's go to the editor, yeah, to see some super simple code. Yeah, you can find a lot of more complex model, more code on the internet, but I just wanna show you that this strive or to implement this technology in current project. So okay, okay, yeah. So let's start with Spring Boot. So I have super simple Spring Boot application, and I have only added a couple of dependencies. Yeah, so I have a simple entity, and if you already use Spring Dart solution in your work, so in that case, switching to a reactive repository will be very easy to you, because you need only to extend reactive CRUD repository interface and create your own, and you can use it everywhere in your program. So you also can write queries if you want to make more complex queries. Now you can see that yeah, I use it very simple and standard way. Yeah, I have a repository, so I can call methods that are in our repository reactive CRUD. So let's look at it. we have pretty standard methods, and I want to warn you about, for example, maybe save all methods. We have this method is not very, I think, easy, and you might you should use it with attention, because here we have a publisher. Spring Data also support transactional for reactive calls, and if we call this method, so we will use we will get a long-term transaction, and it can be very bad in our application. So think about this method when you use it, because it can lead to some problem. And also, for example, because in this method we use concat map, so it's can if you have a lot of objects there, it can lead to performance problems, and you should be very accurate with calling these methods. But it's really super easy to implement such logic in your application, because repository is super simple. Okay, let's see another example. So now we don't have Spring Data, and we will create our connection factory manually and make a request. So I have a Postgres container, and now I want to get connection factory. I use options and call connection factories.get method. I pass my optionals to this method, and now I will get a connection factory object, and on this object I can create method called create method, and now I can work with connection. So I create statement. I have I have parameterized statements, so I bind one parameter and I call execute, and my my stream become flags from result. Now I can work with my result. So I have, as you can see, very simple table with two books. I get column label, and I see that, yeah, okay, I get my book in the end of this stream. So let's return to our presentation. Yeah. Yeah. Already we have drivers for most databases. So in my practice, the most commonly used databases are Postgres, SQL, and Oracle. So you can start to work with both, because Oracle and Postgres have R2DBC drivers, and also in this task, I don't focus. I didn't focus on the performance of the solution yet compared to JDBC, because here a lot of dependence on the driver as well. Yeah, because drivers will improve, and their speed will increase. So by simply changing the driver in the future, you can further speed up your application and improve its reliability. So I recommend you to do your own research for your specific task with R2DBC. And in the end, I want to say, so in such a short period, we have learned only the basic of R2DBC technology. But if you want to know it more deeply, I recommend you to read specification. Also, I recommend you to subscribe to the after creators of this technology, Ben Hale and Mark Paloch. So here's their Twitter handles, and read book about R2DBC by Robert. So thank you all for your attention. Thank you too, all for listening to me. Yeah, can you give a quick overview of the performance of the drivers with R2DBC? Which one are currently most less optimistic? I work only with Postgre SQL, so it's for my tasks. It's pretty good. And yeah, I know that Oracle has their own driver, but they use, as I know, something. They have async driver, and they have an interface for them. So I think, if be honest, it's not fully reactive interface. It's like a real thread pool solution for. So I think Oracle driver will not work very well on high load. Yeah, but I really I don't know, is it true or not, but I saw their presentation, and I think it's not fully reactive. Yeah, do you use R2DBC connection pool? Any comments on this for performance? Here we added R2DBC pool library, but we don't see any improvements in our task. Maybe because we use our application use mostly insert and updates. Maybe on read we will get more. Did you have a chance to compare performance? No. Unfortunately, yeah, I don't have. I didn't have. Yeah. Is there any ORM support planned for R2DBC? As I know, not, because creator of RDBC, they think that Spring Data, for example, is quite enough for most users, for most developers. And yeah, I use it, and it's pretty good for me. All I need, I found in Spring Data R2DBC. So we have 25 minutes. Okay. Thank you all. Goodbye. See you on next talk about Project Loom.